Hi guys, welcome to the new series of Code from Scratch, and recursion is the most important topic of DSA. It is the most important. Without recursion, you won't be able to understand trees, graphs, dynamic programming, and these are the most important concepts that are asked in all interviews, and recursion is the basic of all of this. So it is like must do topic. You just can't miss it, otherwise you will be struggling with DSA forever. So you have to follow the series very diligently. What we'll do is, in this video, we'll cover the basics. We'll understand why recursion, how to identify that a question belongs to recursion, and I'll give you 5 tips of that, how we'll be going about the recursion questions. And in the coming few videos, we'll take one by one a lot of questions, even basic questions. We're going to take a lot of them so that you get used to the process, that identifying the recursion thing, how to explain it, how to write the code. We'll get really used to it. Like, there'll be no hurry because this topic is that important. And why have I picked this topic before stacks, queues, even strings? Because almost all of these topics will include recursive code at some point or the other. Even for binary search, it is possible to write recursive code. So if one of the videos will actually be that, how to write binary search code using recursion. So it makes sense to understand recursion first, so that when we pick up the topics like stacks, queues, binary trees, we'll be able to write recursive code properly. To start understanding recursion, let's take an example. Suppose I ask you to print CFS1, CFS2, 3, 4, 5 times basically. CFS stands for code from scratch. Just to spice it up, I've written that. So what will you do? You will basically tell me that, okay, I'm going to write a for loop, and you're going to output, okay, CFS, and then you're going to output I, right? So what will be the output of this? So this is the output: CFS1, CFS2, 3, 4, 5, right? Very easy code, very basic code, right? This is actually iterative code. So in a lot of places, you'll be asked to write iterative code or recursive code. In a lot of questions, interviewers will tell you, write iterative code for the recursive code that you've written, or write recursive code for the iterative code that you've written. If you have watched my interview experiences, this has actually happened with me, that recursive code was very easy to write. So to make it a bit more complex, interviewer asked me to write the iterative code. So whenever we use loops like this, we are basically writing iterative code. So this is iterative code. Now we are going to write recursive code of the same thing. Now, what is recursion? Let's come to the very basics. What is recursion? In very simple terms, if I have to explain in just one line, whenever a function calls itself, the function is called recursive function. And that's it. If you have understood this much, you have actually understood entire recursion concept. I know it sounds very simple, but again, we'll discuss all the 5 tips, so don't worry. To explain it better, suppose there is a function, and now we are doing something inside the function. Okay, so there are a few instructions, but inside this function, we call the function again. Then this function is called a recursive function. Let's try converting this iterative code to recursive code. So what I'm going to do is, I'm going to write a function. So void func, I am going to basically pass an integer. Don't worry, it will become completely clear. Right now, let me write the code and I'll explain it in detail, so don't worry. So I'm writing that if I becomes greater than 5, basically, then I don't have to do anything. So what I'm going to do, I'm just going to return from there. Otherwise, what I'm going to do is, I'm going to output CFS, and I'm going to output I and F. And after this, what I'll do is, I'll call the function again for the value I plus 1. Now, instead of this for loop, what I'm going to do is, I am going to just call the function and pass the value 1 to it. So now let's try running and see what's the output. So this is the output. The first 5 times that CFS was printed was from the for loop, and the next 5 times, that is CFS 1 to 5, it is from the recursive code. And the output is same, right? It is exactly repeating CFS 1, CFS 2, 3, 4, 5, again CFS 1, 2, 3, 4, 5. How did this happen? Now let's break this function properly and let's understand the basics of recursion. Okay, first point. Why is this function a recursive function? Because the function is calling itself. Here, if you see, inside the function, we are calling function again. We are passing different argument, that thing is different, but we are calling the function again, right? So we'll understand about this arguments, what to return, how to return, all these details we'll understand later. Basically, for now, just keep this in mind, that whenever a function calls itself, the function is called recursive function. Just keep this in mind. This is the most important thing. First thing that we have understood is, that is what is recursive function. Second thing that we'll understand is when to use recursive functions. Now, when to use? Whenever a problem can be divided into smaller, simpler subproblems, we use recursion. Let me write this down also. So first point that we learned, what is recursive function, which is when the function calls itself. Okay. Now, second point that we are looking at is when to use recursion. That is when we can divide the problems into simpler problems. Now see, a lot of times I have seen in definitions, a lot of people say that, you take smaller inputs or something like that. Don't get into all of that. We are not dealing with inputs. We are actually converting into smaller problems. Basically, a bigger problem is divided into a smaller problem. In this case, what was the problem that was divided into smaller problems? So initially we had to print CFS 5 times, right? In that, what we did was, from that we divided the problem to smaller problem. What was the smaller problem? That printed 4 times. After that, we divided into printed 3 times. After that, we divided into printed 2 times. After that, we divided into printed just once. Okay. So this dividing the problem into smaller subproblems is when we have to use recursion. I know it might not be completely clear because this is a very, very simple example, but as we take more and more examples, it will become very, very clear that, okay, when to use recursion. Okay, again, to revise, first thing we saw, what is recursive function? When a function calls itself, it's a recursive function. Second thing that we saw, when to use recursion? Whenever we can divide a problem into a smaller problem, we can use recursion. So actually the 5 things that I was talking about, the first point is this only. Whenever we have to identify that, okay, we have to use recursion, how can we identify? Whenever we can divide a problem into smaller problems, we can use recursion. So this is the first important point of recursion. Okay. Now let's see that how did the function that we write work properly. So initially we call the function and we pass the value as 1. Okay. After that, inside the function we did something and then we called function with 2. So we incremented the value and we passed 2. Now from here we called f of 3. From here we called the function and we passed the value 4. From here we call the function and we pass the value 5. Then in 5 we check that, okay, I value has become 5. Then we return from here. So we went back, we went back, we went back, we went back, and then we came out of the function. So this simple visualization that we actually just did, that okay, from function of 1 we have called function of 2, from here we have called function of 3, from here function of 4, from here function of 5, and then we go back. This is actually called recursive tree. And right now this seems very simple, but in actually very complex questions this will become extremely important. And why are we calling it a tree? Because in complex questions, like say for example Fibonacci, it will start looking like this. Our recursive tree will look like this, which actually looks like a tree, right? So this is the second important point of recursion, the visualization. So we will be drawing recursive tree to understand that, okay, how the function calls are going to happen. Let's just start writing the important points. The first important point that we saw was that we are dividing our problem into smaller problems, right? So this is the first important point. The second important point that we saw that, okay, we have to do some visualization. And how can we do that? We can do that using recursive tree. So using recursive tree, we will actually be able to see that, okay, from this function, we called these 2 functions again. From this, we called 2 times again. From this, we called 2 times again. So we'll see that, okay, which function is being called when, with what values. So as we do more and more questions, we'll be able to do this visualization. And this is extremely, extremely important because without this, you will not be able to understand recursion. This is extremely important. Okay, before moving ahead, let's quickly summarize. First thing we saw, what is recursive function? Whenever a function calls itself, it's a recursive function. Second thing we saw, when to use recursion. Whenever we can divide our problems to smaller problems, we can use recursion. Third thing that we saw that, okay, we can do some visualization using a recursive tree. Now to understand the fourth thing, that is the third important thing of recursion that we have to always remember, we have to understand a bit of memory that, whenever a function is called, what happens in the memory side. So let me quickly explain that to you. Whenever a new function is called, some memory is allocated for it. Let me show you how. Suppose from our main, we are calling a function f. Okay, so now in memory there will be a stack present. Now if you don't know what stack is, don't worry, we'll understand it in simple terms. So in this, some memory is allocated for the data that will be there in this function. So there will be some variables, there will be some instructions and all that, right? So there is some memory allocated for this function. Now suppose from here another function is called, then that memory will be allocated on top of this. So basically this looks like a stack. So this follows last in first out. This basically looks like a stack of plates. So as you keep adding more plates, they are added on top. So this is the ground and you are adding plates on top of it. Okay, and when you start removing the plates, you will remove it from top itself. Similarly, when memory is allocated, say for function 1 memory is allocated over here. Now when for function 2 memory has to be allocated, it will be allocated on top. When function 3 memory has to be allocated, it will be allocated on top. When function 4 it has to be allocated, it will be allocated on top. Now as soon as you are done running a function, it is actually popped out. It is removed from the stack. As soon as you are done with the function 3, it will be popped out. As soon as you're done with the function 2, it will be popped out. As soon as you're done with the function 1, it will be popped out. So this is extremely important basic to understand recursive stack. So let me explain you again what is stack if you don't know. Suppose in our main, we were calling functions like this: func1, func2, func3. Okay. In this case, how will our stack look like? So this is our stack. As soon as you call function 1, okay, so function 1 will be allotted some memory. Now when you are done with this function, what will happen is that, okay, when this is executed, when this is done, when you come back from this function, memory will be deallocated. So basically this will be popped out. Then when you come over here, function 2, memory will be allocated to function 2. Then when you are done with this, this will be deallocated. Basically the memory will be deallocated. Basically this will be popped out. Okay. Then when you come to function 3, this will be allocated some memory, and when you are done with it, it will be popped out. Now you will say, right now you were writing func1, func2, func3. Now you are saying it will be popped out at that time itself. Now that is the catch. Okay. How is this different from what I was doing earlier? Let's write that now. Suppose there was a case from my main, I am calling function 1, okay, and there is my function 1 which is actually calling my function 2, okay, and from my function 2 I am calling my function 3. This is how my code looks like. Okay, now what will happen is, this is my stack. From my main, some memory was created for function 1. Okay, now I go to function 1. I see, okay, I have to call function 2. So now some memory is allocated from function 2. See, when will the memory be deallocated for function 1? When it is done executing. But right now it is not done executing. So when we are inside the function 1, some memory is allocated for function 2. Now when we go inside function 2, there is some memory allocated for function 3. Okay. Now we will go to function 3. We will see that, okay, we have to do some instructions. We do it. And once we come out of function 3, this will be deallocated. So basically this will be popped out. Then what will happen? We will go back. So we came over here. We are done executing. So we will come back now. We come over here. Then what will happen? We will pop out function 2 ka memory. Then we will come back over here. Now when we are done executing function 1, we will pop out the memory. This is the very important difference. Some of you might already be aware of it, but because this is so important basic, I am repeating it again. See, whenever we are calling a function after finishing a function, like if func1 is there and we are done executing it, then it will be deallocated. But if it is not done executing, like from inside this function itself, I am calling function 2, then in the stack, what will happen? The memory will be allocated on top of that. Okay, so this is how our stack will look like. Now, why is this important for recursion? Let's look at that. Suppose we have a recursive function, this, okay. Now from inside this, we are doing something and we are calling the func again. We are calling this say 5 times. 1, 2, 3, 4, 5, the code that we just wrote, okay. Now what will happen? This is a stack. We created some memory for this func. Now from inside this, we are not done executing. So another memory will be created for this func. Then another memory will be created for this func. Like this, the memory will be created in stack, will be allocated in stack 5 times. So basically this is called as our recursive stack. And this is the next most important thing for our visualization of recursion, recursive stack. Another doubt that can come over here is, because this function is same, why are we writing it again and again, like on the stack? Isn't it the same function? Then we should just pass it. Now for that, let's come back to the example that we wrote. Okay, in the function we had initially passed 1. Okay, so when we pass that one, say we had a variable over here, value say equal to 1. So in this time when we pass the function, we will store 1 value. Now when this function is called with 2, we will store this 2. Then after this, when the function is called, we will have the value as 3. After this, when it is called, we will have the value as 4. After this, when it is called, we will have the value as 5. Now the values and the local variables that we have are stored again. Like every time we call a function, all the variables are allocated again. All the local variables that will be there inside this. Don't bother so much about arguments and all. We will come back to that later. Whatever local variables will be there, that will be allocated again. So suppose in my function over here, I wrote int x equal to 10. Now when memory will start allocated, like the first time I create a function for x, there's some memory allocated. Then again when it is called, for x some memory is allocated. For again x some memory is allocated. Again some memory is allocated. Again some memory is allocated. So this is recursive stack. This is the third most important point, that is recursive stack. Now these two are actually used for visualization. See, these are the terms that we have to know. Like in binary search, we talk about search space, right? Similarly, these are just some jargons. And see, there are just 5-6 things. And once we understand this, when we will start taking more and more examples, they will be completely clear. In the starting, I understand it will require some patience if you are hearing these terms for the first time, and that's completely fine. Trust me, when you start doing some questions, after 1 or 2 questions, it will become very, very obvious. And then you will be very, very thankful that, okay, you are used to it. Because in interviews, what will happen? A person will tell you, how are you visualizing it? So you might have to like show that, okay, the stack will look like this. Or suppose you are able to draw on whiteboard, you will just draw the recursive tree that, okay, this is how the recursion is happening. You will also help interviewer realize that, okay, you have understood recursion properly. Okay, before moving ahead to the fourth point, let's quickly revise. Till now we have seen that, okay, whenever we can divide our problems to smaller subproblems, we use recursion. Second thing that we saw that, okay, we can visualize recursion using recursive trees. Third thing that we saw, how memory is allocated. That is another way of visualizing recursion by using recursive stack. Now to understand the next point, let's come back to our code. So this was the code that we have written. Okay. Here I had added this extra line. If I is greater than 5, return. How many of you are wondering that why have I written this? And how many of you know why have I written this? Let me know in the comments. Now let's see if I remove this, what happens. Let's try removing this and let's try running. Okay. So here you can see that CFS was called for so many values, and in the end segmentation fault happened. Why segmentation fault happened? Because a stack overflow happened. Why did stack overflow happen? Because there was no stopping condition. What is that? See, initially I called the function and I passed the value 1. Now from the function from 1, I again call the function with the argument as 2. Then I passed the argument as 3, then 4, then 5, then 6, then 7, then 8. I went ahead like that. And every single time I was calling this function with the value 1, 2, 3, 4, 5, some memory was getting allocated in the recursive stack. So for function with value 1, some memory was allocated. Then for value 2, some memory was allocated. Like this, memory kept getting allocated till this stack overflow happened. Yes, that is the error, and that is how the name of the company has also come, stack overflow. When does stack overflow happens? When there is no stopping condition, we are basically going ahead and we are basically out of memory. To understand this point properly, let's draw our diagram again. So from our main, what did we do? We called the function for 1. So we allocated some memory in the stack for f of 1. Okay. Then we called f of 2. So some memory was allocated for f of 2. Then we called for f of 3. So some memory was allocated for f of 3. Like this, we kept allocating some memory. Okay. And we did not put any stopping condition. So f of 4, some memory was allocated. Like this, we kept allocating till we went out of memory. See, memory is limited. It is not infinite. It is limited. So as soon as we went out of the stack, we got the error as stack overflow. And this is extremely important point. A lot of people will ask this, that okay, when does stack overflow happen? So when does this happen? When there is no stopping condition. When we are not telling a recursive function that okay, this is where you have to stop. And when we tell our recursive function to stop, that condition is actually called base condition. And that is the fourth most important point, because every recursive function has to have a base condition, otherwise stack overflow will happen. So in our code, what was our base condition? Let's look at it again. So I'm basically doing undo now. So this was our base condition. Basically, I said that whenever I value exceeded 5, you don't call the function again, you just return from there itself. See, in my iteration, what happened? I had a for loop. So there was a condition that, okay, where I have to stop. Whenever I becomes less than or equal to 5, I have to stop. After this, the output statement should not be called. Similarly, in recursive code also, there has to be a base condition where we have to stop. Okay, so here this is the case. One thing that I would like to point out over here is that a lot of people, while explaining recursion, what they will do is they will take the example in the opposite way. They will take like 5, 4, 3, 2, 1, or they will start printing the product like 5 into 4 into 3 into 2 into 1. So what they will tell that, okay, your input is reducing. From 5 you are passing I minus 1, so you are passing 4, you are passing 3, you are passing 2, you are passing 1. So they will tell you your input is becoming smaller. Which is wrong. Your input should not become smaller. Your problem should become smaller. See, here the problem was that you had to print CFS 5 times. That became smaller to you printing the CFS 4 times. That became smaller to printing the CFS 3 times. That became smaller to printing the CFS 2 times to 1 time. See, these basics are extremely important, because when we do more tough questions, this is like very, very basic, right? We are just printing right now. When we do complex questions, it will be very, very important to understand that, okay, why do we need recursion over here? That is when we'll understand that, okay, which problem are we reducing to a smaller problem? So that is why these basics are extremely, extremely important. Let's quickly revise the 4 points that we have discussed till now. Whenever we divide our problem to smaller problems, we use recursion. Then the second thing that we saw that, okay, we can visualize recursion by drawing a recursive tree. Basically, we will see which function will be called after which function and how the entire flow is happening. The third thing that we saw that how recursive stack is built, basically how memory is allocated to the functions. We also saw when stack overflow happens, and when will that happen? When we have not given the base condition, and that is our fourth point. Every recursive function has to have a base condition. If a base condition is not there, you will have stack overflow. This is so important. You just cannot miss this in your code. Base condition is very, very important. Let's come to our fifth point, and that is called recurrence relation. Now, this is the last jargon that we are dealing with, I promise. Okay. And what is this? This is basically a mathematical representation of the function that we are dealing with. For example, if we were dealing with Fibonacci, okay, then we would write that, okay, f of n is equal to f of n minus 1 plus f of n minus 2. All of you have done this in school, right? Similarly, when we find factorial, we write n into f of n minus 1. This actually, if you see, this is actually recursive functions only. So if there is a function, you can actually call function f of n minus 1 plus f of n minus 2. You can call f of n equal to n into f of n minus 1. So actually these two functions we are going to take in the next videos. So what I want you to do is, I want you to try writing the recursive tree and the recursive stack for these two functions, because that is extremely important for you to be able to visualize how the recursion is happening. Without that, we will not be able to move ahead. See, this is called recurrence relation. Basically, we are denoting it in a mathematical way. And this is actually asked in a lot of interviews. In my Uber interview, I was asked, can you tell the recurrence relation? I was given a question and I had to write the DP solutions. So initially, the interviewer asked me to come up with a recursive solution. And instead of writing the entire code, the interviewer told me that you can just tell me the recurrence relation. And after that, you can write the code for the DP solution itself. So this is how I explained that, okay, I am going to do recursion. Suppose someone tells you, okay, the function that we wrote today that, C out CFS of n 5 times, how are you going to explain it in one line? So basically, you're going to say that, okay, function of n, what is it doing? It is doing print CFS of n and CFS n, and then it is calling function of n plus 1. Right? This is what we are doing. So we are starting with n equal to 1. We are doing for n equal to 2, 3, 4, 5. And after this, you have to also tell the base condition. That is, where are you going to stop? That is, when n is greater than 5, you will stop. Or when n is equal to 5, that is your last condition. So basically, whenever someone asks you what is your recurrence relation, basically how your recursive function is going to look, you can tell in one line itself by this, and you will tell your base condition. I know this is too much information already, but let's quickly revise the 5 points that we saw, because these are the 5 points that we are going to see in all the upcoming videos for all the upcoming questions. First thing, we'll see what is the problem that we are dividing into smaller problems, because of which we can apply recursion. That is the first thing that we will see in recursion. So that tomorrow when you see a new question, you are able to identify that, okay, this is why I have to use recursion. Second thing that we will do, we will try to visualize how recursion is happening by making a recursive tree. Third thing that we will do is we will see how memory is allocated in recursive stack. Fourth thing that we will do is we will see what is our base condition, that is where our recursion has to stop. Fifth thing that we will do is that we will write a recurrence relation. Basically, we will try to show our entire function in one mathematical equation. We will tell that, okay, this is our relation. This is basically our function in one line. To remind you, we started our video by writing some iterative code, and then we wrote the recursive code out of that. Now let's quickly discuss the pros and cons of writing recursive and iterative codes. Before I tell you the points, you should actually try thinking of them yourself. The first point that I can think of is that, okay, we are having a recursive stack in recursion, right? So basically when we write a for loop, there is no extra space that we are using. But because we have a stack, we are allocating some memory because of it. And that is why recursive solutions will take more space than iterative solutions. Another point is that recursive code is actually very short and easy to read. But what will happen is that because of this, sometimes it may become difficult to understand. See, because there will be a base condition and there will be like, you will have to maybe, draw a recursive tree to visualize it properly. In iterative code, what might happen is because there's a loop, you can easily visualize it comparatively. So sometimes it might be more difficult to understand, but what will happen is it will be more short and it will be easy to read. I know what a lot of you are thinking, when iteration takes less space, when it is easier to understand, why are we actually studying recursion? For that, we have to do some more difficult problems. A lot of problems you will see that, okay, recursive code is much simpler than iterative code. Actually, a lot of times it happens when you get used to recursion, that when interviewer tells you to write the iterative code, you get very, okay, how am I going to convert this into iterative code? And that's what happened in one of my interviews, because I was done and I had so much time left. To make it a bit more complex, to make it a bit more interesting, my interviewer told me that write iterative code instead of writing a recursive code. So from the next video, we are going to try solving a bit more complex problems. Try visualizing the recursive tree and recursive stack for Fibonacci problem and for factorial problem. We are going to discuss them in the upcoming videos. See you tomorrow. I hope this was helpful. If you have any doubts, let me know. I'm here to help you. Let's solve recursion properly, because it's the basic of a lot of concepts. See you. Tata.